Alrighty, I think we are live. Hello, everyone. Welcome to the seventh episode of Observability Unplugged. Super excited to have you all here. My name is Kunal. I'm working as a DevRel engineer at Randoli, and I'm joined by Rajat, founder and CTO at Randoli. And this is very exciting because this is the first episode of the new year. So, Happy New Year to all of you. I know we are in February right now, but still, we've been doing these episodes consistently. We started last year, and we've already had six episodes where in each episode we talk about a certain topic related to observability AI because there is just so much happening in the AI and observability ecosystem. So our main aim with starting this series was to come on and bring a guest from who's active in the ecosystem and just share the information with all of you because it's always good to share value and it's always good to keep you all updated, right? And this one's special because we are going to talk about eBPF and something we are calling, if you have read the title, we are calling this as the eBPF shift in observability because uh, what it means in practice, we are going to talk about that. In the recent years, there's been a lot of discussions around eBPF's use cases in a lot of different domains, right? It started with networking, then we talked about security, but today specifically, we are going to talk about how eBPF is being used in the observability ecosystem and what value it actually is delivering. And we have got a very special guest, Bill. Thank you so much for joining us in today's podcast. Would you like to tell everyone a bit more about yourself and what you're doing these days?
Sure. Thanks for having me. I'm Bill Mulligan. I work at Isovalent, which is part of Cisco, and I'm a maintainer of the Cilium project, which is a graduated project in the Cloud Native Computing Foundation, actually the second fastest moving project in the whole CNCF. And I'm also a maintainer of the eBPF.io website and really involved in the eBPF ecosystem through the eBPF Foundation, sitting on the governing board there, and working a lot with people to make eBPF kind of the strategic infrastructure technology for the future.
Amazing. Yeah. Super excited to have you, Bill. Thank you so much for taking out your time. Just before we start, I see a lot of people are starting to join in. We are still early in the session. So, there's a few housekeeping things for all of you. We are live streaming this on YouTube and LinkedIn. So, either you can join from either of the platforms. But if you want to chat with us, I would prefer if you can also join the YouTube stream as well, because sometimes LinkedIn lags while you chat. So, I wouldn't want you to have that kind of an experience. This is the link to the YouTube live stream. Feel free to join this one. And yeah, feel free to ask all of your questions if you have related to this particular topic. We love to take out questions, and we love to take out some time after the initial questions that we both have to take your questions related to eBPF. How are you using it today? And if you want to get started with eBPF, those sorts of related topic. All right, I think we can start, right? So before we get into eBPF itself, Bill, I think it's worth taking a step back for a second because this quote unquote shift that we are talking about, right? It didn't just happen in a snap. It sort of it's years of change we have seen in how we are building and running systems, right? So when you look at cloud native systems being built today, what has actually changed according to you that has sort of made the old and traditional ways of doing monitoring just stop working the way they used to previously?
Yeah, I think there's a lot of different changes when we're kind of moving to a cloud native infrastructure. I think the biggest one is just like the speed that you're moving at. Instead of having really long lived VMs or bare metal machines, suddenly you have containers. I think there's some statistic from Google they're like changing 1 billion containers a second or something. So there's a lot more churn. Things are a lot more ephemeral. Ephemeral. You can't just kind of like pick thing and say it's going to be the same the next year, the next month, the next day, even the next hour. So it's how can we deal with a lot of change and churn in the system in a scalable and repeatable way without completely losing our mind. I think that's kind of like the key thing in cloud native is the pace at which things change is increasing. And so with that comes a whole new set of challenges. And so I think that's where a lot of the cloud native tooling came from is things are moving faster. How can we keep up with this pace of change?
Yeah, I totally agree with that. And I feel that, a really good example for this is the CNCF landscape itself, right? From the day it started to now what it is. I mean, I still remember whenever I present about the CNCF landscape, I've given a couple of talks on this topic. It takes hell of a lot of time to download it now, right? And just to put it on the slide itself, right? So it's so huge, right? And it definitely makes sense. Systems have become more dynamic, more distributed, and that's why I feel, because we are talking about observability, right, we are now starting to see eBPF added in that conversation. So before we talk about specifically in the observability lens, because that is what we are going to discuss, I think it will help to do a quick primer for people, because there might be some people who might not know what eBPF is, who might have just started working with eBPF, but they would like to understand it a bit more, right? So there is a lot of different use cases about eBPF now, but at its core, what was it originally trying to solve when the project came into being? If you, let's say, had to explain eBPF in very simple terms, what problem was it designed to address as a project in the first place?
Yeah, so eBPF as a technology is about 11 years old now. And the problem it was trying to address at the time is Linux at the time was 25 years old. And as you kind of progress in technology, you have a lot of things, and change becomes harder to do things. And so the Linux kernel kind of slowed down. It's deployed on more than 1 billion devices worldwide, and everything from a satellite to a phone to a lot of servers in your data center. And so the question is, when we're deployed on that, like, how can we make sure there's stability across all these different systems we need to run it? And with that, kind of the pace of innovation kind of slows down. And on top of that, like, a lot of people aren't running the latest kernel in their environment. And so you're not able to kind of change the fundamental operating system that you're working with as the pace of technology is increasing. And so you kind of have these two things pulling in opposite directions. Things need to move faster, but we can't innovate as fast as we used to anymore. And that's kind of where eBPF stepped in. It brought innovation back into the kernel. And the way that it does that is it allows you to reprogram the kernel to add new functionality that you need. And so at the time, some of the top use cases are, right, where this is kind of like the advent of streaming, more data coming through. Actually, one of the early adopters was Netflix. It's like, how can we process more packets, and how can we get observability into all the data that we're sending across the internet? Another one, Facebook. We're getting a lot of memes, a lot of cat pictures. How can we, get the raw throughput increasing in our system? And another one was Cilium. It's like, how can we make networking native to the cloud native world? And so looking at kind of all of these, what eBPF allows us to do is to insert programs into the Linux kernel to change functionality on the fly. And the example that a lot of people usually use is eBPF is to the kernel what JavaScript is to the browser. So if I take you back a couple more decades, back to a classic 1990s website, what you have is this static page where you're just reading off information. And that's kind of like what the kernel was a decade ago. Like, here's the functionality, and this is what you get. And now suddenly with JavaScript, you're able to add functionality. So as a user interacts with the web page, you do things like click the button, zoom, it's interactive and it changes based on input. And so that's exactly kind of what eBPF does in the Linux kernel too. As new inputs come in, programs are run and functionality can change. Another example I like to give is like the App Store, right? Before, you used to get your mobile phone, you'd flip it open, type some numbers, and it just had the functionality that it had, right? But when the App Store came along, suddenly you could add new programs to do things that you want to do. Be like, say, now I want to get from A to B. Well, I can install Google Maps, open it and look at the route, and then I can install Uber and call a taxi. So you can add new functionality to an already existing piece of hardware. And that's really cool, because rather than waiting for these long innovation cycles in the kernel that can take a couple of years to come to consensus, and then a couple more years until you actually deploy that age of kernel into production, you can have an idea, you can write a program, and you can deploy it into production all in the same day. In fact, there's even a talk from Brendan Gregg, who's one of the kind of early innovators of eBPF, and he was talking about how customers would ask him questions, and by the end of the meeting, he could come up with an eBPF program and answer their questions about the systems that they had, right? So instead of years-long innovation cycles, it brings it down to, weeks, months, hours, even the span of a meeting. And so that's what makes eBPF exciting, is bringing innovation back in the kernel, which is kind of like the fundamental thing that we're all running on. And when we're able to do that, we're able to add new functionality. And what that unlocks is creating, I would say, like a new era, a new generation of infrastructure software. We can add the functionality that we need on the fly in exactly the way we need. And I think that's what makes eBPF so exciting for me, and why a lot of companies are starting to bet their whole kind of strategic choice of platform, of the stack of technologies that they're building, the projects, the products, the services, the tools that they use on eBPF.
Yeah, that totally makes sense. And I think that's why, because eBPF is so foundational, it works at the kernel level. We are seeing use cases in so many different domains, right? We are seeing networking use cases, observability use cases, which we are going to talk about today. We are also seeing use cases of it in the security aspect as well, right? And there's a very interesting comment by someone saying kernel man in the middle observability agent to avoid application instrumentation. It's interesting. Yeah, we are going to talk about instrumentation of eBPF as well. But for people who are new to eBPF and would like to know more, there is a very interesting film that was released by the community on eBPF, and this sort of takes you through the entire journey of how eBPF was formed and what was the idea behind it. So we'll make sure to check it out. It's on YouTube. It's free to watch, by the way. All right. So now that I hope the audience now is aligned a bit on the idea of eBPF and why it came into being. Now let's talk about a bit from the observability perspective, right? Because that's what we are going with today, right? So in conversations around eBPF being used in observability, right, the first angle that I've seen come up in the discussion is around eBPF based instrumentation, because instrumentation is sort of the first step towards gaining observability, right? You have to instrument an application. So what actually has changed here if we compare to the traditional way of instrumenting applications? According to you, how is eBPF based instrumentation a bit different, because everything starts from here?
Yeah, so I think this is a little bit what the LinkedIn user was commenting about. In the traditional way, we need to add instrumentation to our applications that may be requiring changes to the application code. But with eBPF, you're actually looking at it from a totally different way. So instead of having to instrument the application code, you're actually instrumenting the kernel itself. And this is really cool because it doesn't require any changes to the application code. And the other thing, since kind of like the kernel is the thing that all the software on top is relying on to be able to actually access the hardware underneath, what you're able to do is to see everything that's happening on the machine. There isn't like, oh, this part of our application we couldn't instrument. It's like, no, we've instrumented the whole kernel. So everything that you want to see, you can see. And I think that's kind of the exciting part. It allows you really deep visibility. It allows you to have complete coverage of whatever you want. And it also allows you to have very granular visibility too.
Yeah, that makes sense. Yeah. And I think because eBPF we are talking about low level signals, right, with eBPF, because it's so close to the kernel. It gives you that, what you mentioned, it gives you the deep visibility without entirely depending on the application instrumentation itself, right? And it gives you a bit more than that. So from a practical standpoint, right, when we are talking about moving things to the kernel level, what kind of things are there that actually makes the teams visible? What kind of visibility do we get that we couldn't really see before? If you can give some examples here.
Yeah, so I would say this is both the power and the peril of eBPF, is that you're actually hooking into, for example, the syscalls that the application is making to the kernel. You're looking at very specific points like open this file, connect to this socket, read this file, right? So you can pinpoint things specifically, but that's a huge amount of data that you can have. And actually looking at the comments right now, there's one from Derek, and he's talking about, I'm curious if eBPF has improved at all on the performance front. There's a bit of a bottleneck to leverage at scale years ago. And so, right, really powerful. You can see everything. You can have complete coverage. You can have really fine-grained ability to look into that. But that's also dangerous because you get a lot of data, a lot of information back from that. So it's a superpower technology, but you need to use that power wisely. I don't know exactly what Derek's kind of like use case is, or like in what kind of sense he was looking at it. But if I had to guess, where he ran into performance issues is that he was trying to collect too much data, right? And so you can have this really granular thing. You can see every single system call that's happening on your host, right? But in a lot of cases, you don't care about a lot of that data. I think this is where people need to, eBPF is a very low level tool. What you actually need to do is you don't need to have data, you need to have insights. And eBPF gives you data. You need to have the ability to turn that into insight, whether that's through a project that you're using, like Cilium, like this is how we should do routing in our network, whether that's observability is like we're only looking for this specific things, whether it's security, being like, okay, we only want to monitor these specific files rather than every single file access on the system. Like, I think this is what people probably misunderstand about eBPF. They think it's like, oh wow, it's like this like perfect solution that solves all problems because it's super granular. But data is very different than insights, especially in observability, right? Like, I think we're kind of past the point where like more data is better in observability. I don't think anybody's really trying to make that argument. What people really want is like, what's going wrong on my system? Why is it consuming too many resources? Why are we having this cross zone traffic? They want to have the actual insights into their system. They don't really care about the data. eBPF is just a tool, like a means to that end. It allows you to really dive into this granular data, but then you need to be able to use that data to draw the information that you actually need. And so I think eBPF is this powerful tool, but you need to use it wisely.
Yeah, 100% agree with that. I think that's one thing I'm very sort of adamant about, that there's no shortage of data, like you said. In fact, I think we have too much data all around within observability itself. It's gathering those insights and presenting it, and finding that right balance, even with data collection too, right? It has made everything easy to collect data, but I think we're sometimes collecting too much data to the point that it's detrimental to the application that we are running, etc. So that's a great point. I love the way you explained it. So thank you.
Yeah, definitely. Like, more data doesn't mean better data. There is like better types of data, right? That's eBPF. You can really do fine-grained instrumentation of just the things you're looking for. But just because you have more of it doesn't mean that you're going to find the solution to your problems.
Amazing. Yeah, thank you for sharing your perspective. And we are getting some interesting questions as well. I think we can spare a few minutes after the discussion to answer a few questions, but keep your question coming, folks. It's really interesting to see.
Yeah,
Yeah,
we
thank
can
you so much.
check on those questions, I think, especially when we hit a particular section as well, instead of waiting till the end. So I'll help out, and I'll point out if some of these things are actually probably good when we talk about observability itself, so we can get Bill's perspective on those. Yeah.
Absolutely. Yeah. Thank you so much for sharing your question, folks. Okay. So we have talked about, how eBPF can, how eBPF can help in the observability aspect, right? Uh, how it changes conceptually, especially once visibility moves into the kernel level, right? I think you gave some really nice examples there, Bill. I think things become a bit more real once we look at Kubernetes specifically, because today we see that's where most teams are running their entire infrastructure out, right? It's either Kubernetes or it's a combination of, let's say, Kubernetes and VMs, and but the center component is always Kubernetes, right? And that's where most of the companies and most of the teams are looking to build their observability solution on. So Rajat, I think this may be a good place for you to jump in and
Sure.
take us on the Kubernetes side of the discussion.
Sure. Yeah. I think when Bill started, you mentioned that, especially in the Kubernetes world, there's a lot of things that are ephemeral, right? So, in fact, I saw one of the CNCF service that said the average lifespan of a container was a couple minutes, maybe, probably less. So there's a lot of things that come and go, and especially from a security perspective and a traceability perspective for other performance reasons, or a debugging troubleshooting perspective, you need to be able to track these in a sort of a scalable way. And whatever we had up to that point wasn't great. So can you elaborate a little bit more about the security aspect and sort of like the network tracing aspect? because I thought those were for me, when I talk about observability, though, I consider, security and sort of like the visibility as part of it, right? I mean, the observability has sort of, the scope has kind of grown, right? It's not just you're thinking about performance or monitoring. So could you elaborate a little bit more about um, the security aspect of it and the traceability aspect of it? Because I think that was one of the first use cases that I saw people getting super excited about when it came to eBPF.
Yeah, so eBPF, I think observability, security, and traceability, they're all kind of like interrelated, and one doesn't always lead to the other. With eBPF, right, you're able to, on the security side, like the interesting thing is you're able to very finely tailor kind of what you're looking for. So rather than being like, I want to look at every single file open, I want to look at just these specific security relevant files. So is somebody trying to access like the passwords file, right? I probably want to like know about that, especially if it's like, in unknown application. So with eBPF, what's really cool is you can like really tailor down the observability information that you're doing. And also being able to be in the kernel, you can see which process is trying to do which thing. And so by having all of that like kind of host level information, you have really detailed information. It's this process is trying to open this file, right? That's a lot lower level than like, okay, this application is calling to these other application. You can actually trace it back to actually the parent process. You can do things like process ancestry trees, and then actually seeing what each of those processes are actually trying to do. And then, yeah, like how eBPF actually functions, I guess this is going back to what we were talking about before. It's a tool, like being able to use it for higher level use cases like observability, like security, traceability. That's when you need to turn this tool into an actual project or product. Like I think very few people in this world are going to be writing their own eBPF programs and deploying them into production. The people that are going to do that are companies like Meta, like Netflix, like Google, that have their own kernel teams that are actually probably contributing patches upstream. Most people in this world are going to be consumers of either projects or products that are leveraging eBPF as the underlying tool that allows them to achieve the outcomes that they're actually trying to do, whether it's around observability or tracing or networking, security, scheduling. And if you're doing that, you really need to evaluate how the tool is actually using eBPF, right? Is it trying to do everything, or is it trying to do just the specific things that you want to? And I think that speaks a little bit to like Derek's comment too, is the actual implementation, right? So here's the outcome that I want. I want better observability. I want better security. And how do we implement that? Well, if you use eBPF as this powerful tool, we can look at everything. Yeah, that's going to cause a lot of performance overhead. Right? Same thing with observability. It's like, I want to observe everything on the system. That's going to cause a lot of performance overhead. But if you implement it like I care in my environment, it's extremely IO intensive, right? So you're just looking at those specific things. What are the few things that we can monitor to understand that? And you can use eBPF to really dig down to the granular detail for that. But if you're trying to like, I'm trying to look at what every single process on my system is doing, yeah, that's going to cause a lot of overhead. So a lot of it is about the actual implementation that the project or the product is using. eBPF is just a tool.
And yeah, that's a great point. So I mean, if anybody who's looking to kind of leverage some of the capabilities that eBPF provides, then they should be looking at things like Cilium or Kubescape that is that's using from a security perspective. There's a ton of other projects that ends up using eBPF as an underlying technology. But people should be looking at these projects that are, making it more, I guess, end user friendly. That's built on top of eBPF, right? Yeah.
Yeah, absolutely.
Yeah. So my next question is actually, it's a bit of a sort of counterpoint to what Derek's talking about, right? So, you can get observability for free, right? So that's one of the sort of like one of my pet peeves. Any kind of instrumentation is going to impose some level of overhead. But what I would argue is that the overhead that comes from eBPF might actually be less than what some of the agents that are running in user space, right? So whether it's a JVM instrumentation agent or some other code level type of agent, I would argue that eBPF would an eBPF approach would have less overhead. Is that always the case, or am I off base? I would love to get your thoughts on that.
Yeah.
Let's
You want me to dive into it?
Yes. Let's
Is this always the best solution? I don't know if I'll be able to answer that definitively, but I think maybe the part that we did skip over earlier is talking a little bit about the architecture of eBPF and why so many people kind of love it for use cases like observability. So what eBPF is doing, so you're writing your eBPF program in C, in Rust, in Go, in Python, and you're loading it into the kernel. So there's kind of two steps here. One, there's a verifier that makes sure that the program is safe to run in the kernel, that it won't crash or otherwise harm the system. This is really good, so we don't have something like the CrowdStrike incident, if people are familiar, where they took a lot of the world's IT offline. And then it goes through a JIT compiler. And what this compiler does is basically turn it into machine code that's going to run basically as fast as natively compiled kernel code. And so if people aren't kind of familiar with dealing with kernel space and user space and what the difference is, basically the closer you can get to the hardware, like in general, the faster your code is going to run. And so by loading things into the kernel, your program will in general run faster. And the other thing that it's saving is what applications in user space have to do. So things that aren't running in the kernel, they have to transition. They have to make syscalls from user space into kernel space, being like, hey, kernel, can you go do this? Whereas the difference with eBPF, it's actually running in the kernel itself. So it's pulling the information directly from the kernel. All that's happening in kernel space. And you don't have the overhead of being like, okay, this is happening in the kernel. I need to pull that information from kernel space into user space. So this whole like transition and the overhead of that, you're also skipping too. So based on the architecture of eBPF, like 1 through the JIT compiler to kind of running natively in the kernel, you're going to get a lot of performance benefits from that. And then the other interesting thing is once again, going back to the implementation, it's not just, do you have eBPF? Check. It's like, how are you actually using eBPF? And I think this is one of the cool things that we're doing right now in Cilium and also in Tetragon, is you can be really smart about how you're actually using eBPF, right? And I think that's the cool part. So it's not just, it's like this natively compiled like kernel code that runs really fast. It's like you can also do other things. Like, so some things that we do is, for instance, for security data in Tetragon, you need to pull like relevant alerts from kernel space into user space, but maybe you don't need all the alerts, or you can aggregate them together so you can look over time. So rather than always pulling information immediately, you can group them together and send it to user space. So it's not just this kind of continuously running process. And by that, we're able to lower the overhead that was already extremely small even more. So it's implementing, not just implementing eBPF, but being smart about how you implement eBPF too. And so I think the cool thing about running in the kernel is that there's a lot of optimizations that you can make. Once you're running in kernel space, you can do smart things with the code too. So I can't answer it's always faster, but the cool thing about kind of instrumenting the kernel is it gives you a lot of flexibility that things that are running in user space don't have access to. One, in terms of like how fast I can run the code, but then actually just fundamentally, can we discard some of this data? Can we filter it? Can we aggregate it? And do those things in the kernel before you even have to make this transition from kernel space into user space too.
Awesome. That's actually a great point. I just wanted to kind of bring that up because that my own experience shows that the eBPF stuff, the eBPF-based approach is generally faster for the very reasons you kind of outlined. I just don't want to make a general statement like you said, but certainly that's what I've seen.
Yes, I have too.
All right. I've got a follow-up question, but I'll wait until we get to sort of like the challenges part. It's very related to this, but I would let Kunal take over and talk a little bit more about how eBPF is now being leveraged into observability side, especially with hotel in the mix. So Kunal, why don't you take it away from here?
Sure. Yeah. I just want to say I was loving the discussion and love the way Bill answered the last question. Very, very grounded way. But because we were talking about traceability, right? There is just one question which is related to this. I think we can quickly answer it. This person is asking about context propagation support in eBPF.
Oh, that's a good question.
Did you?
No. Go ahead. I want you to answer, Bill.
Yeah. I think this is kind of like what context are you trying to propagate? And this is once again like eBPF is like the underlying tool, and then you need to usually enrich that information. So like in Cilium, I can tell you about like the context propagation that we're trying to do is like, what is the actual identity of this pod? So as we're connecting pod A, like front end to back end, we can say like, this is front end, this is back end. And we need to actually like pull that information from the Kubernetes API. And we give everything Cilium identities, and through those, we're able to like propagate the context of this is front end, this is back end, they should be able to connect, or like front end A can't talk to database B. And we can do that through things like network policy. But like the thing about eBPF, it's running in the kernel. So the context that it has is things like process ID, like file. It doesn't have, right? The kernel actually doesn't even know what a container is. It has things like C groups and namespace, and that's the things that the kernel knows. So eBPF is going to know, okay, this is a process running in this like namespace, right? And if you want to tie that up into Kubernetes related context, well, you need to give that context back into eBPF. And you can do that through things like eBPF maps. And that's why you're actually usually relying not on eBPF itself, but you're going to have a project like Cilium, for instance, in between, that's going to be able to provide, or OpenTelemetry, that's going to be able to provide that context to the eBPF programs, and then take what the eBPF programs and then bring that back up into the Kubernetes context. The thing is, it's a very low level tool, and you need to give it that context and then take the information and put it back into context, because eBPF itself doesn't have that.
You explained it really well. Thank you. That's actually a good question and a great answer. Thank you very much.
Thank you so much, Bill. And I'm sorry for some of the people we are not able to see your names. So we can't give you a shout out, but thank you so much for asking your question. Keep those questions coming in, folks. And I'm seeing a lot of interesting questions, and we'll be taking them in the middle of the conversation. So, okay, we've talked about Kubernetes observability, right? Rajat dwelled into that, and we sort of went into that route. But I want to zoom in a bit more here and talk about implementation, right? Because we talked about instrumentation, we touched upon that topic in the earlier part of it conversation as well. And when we talk about instrumentation, as Rajat mentioned, there is a discussion that happens. A question that commonly pops up is eBPF or OpenTelemetry, right? Both cater to different use cases, and this, in my opinion, confuses teams as they see multiple ways of approaching it, right? So because there are a lot of options, and teams sometimes wonder which one to choose versus the another, I want to ask you, Bill, like, is this even the right way to think about it, first of all?
I mean, the first problem is OpenTelemetry is using eBPF, so you're not choosing one or the other. If you're using OpenTelemetry for like some of the things, obviously it's a very big project, then you're already using eBPF, so it's not an either or. You're actually already getting both.
You're very complementary, yes.
Yeah. And so I guess tying it back into like the earlier parts of our conversation too is like, it's like looking at two different things. So you can think of, right, OpenTelemetry is more of the application running in user space, providing the context, and eBPF is this underlying tool collecting the information. And so you're getting all this observability data, and then you need to provide the context and draw the actual insights out of that. And so that's where something like OpenTelemetry comes in. And so an example of this, like the OpenTelemetry profiler is using eBPF to profile applications, and then it pulls all that information and it gives you the actual application profile. I don't know if they do icicle or flame graphs, but actually looking at like, okay, which part of the application is consuming the most CPU cycles. And so that's one example where OpenTelemetry is using eBPF to collect data from the kernel and then bring that into the context of Kubernetes or your application, and then actually providing you the insight. Okay, if we can change this part of our code, we can make our application run faster. And so in a lot of ways, they're going to be working hand in hand. I think it depends on how you want to do that. Like some people, if you're instrumenting, there's also OpenTelemetry. You can use OpenTelemetry to just instrument your application, right? And then it's you're instrumenting your application code. Then you may not use eBPF for that part of it, but there's many different things you're trying to do. There's also, right, OpenTelemetry is like a standardized way to ship observability information, right? And so eBPF isn't doing that. What it's doing is collecting the information. eBPF is very good at collecting information that you want to know from the kernel, and then it's up to you how you actually do that. And that's where something like OpenTelemetry can come in. So I don't see them as competing. I actually see them as really complementary.
Yeah,
That's actually the best way to put it. Yeah. Thank you so much.
I completely agree with that. I think like the eBPF profiler is one of the great examples of how they're working together. And I've certainly seen other approaches where, like for tracing, instead of relying on application level agents, where there are some projects, even within CNCF, that have attempted to do application tracing using eBPF. There are some challenges around that, which we'll talk about soon. But those are some of the other areas that I have seen around trying to use eBPF for things like tracing and profiling. Yeah. Sorry, Kunal, go ahead. I didn't mean to cut you off.
No worries at all. Yeah. I just shared a link as well in the chat for everyone to look out. So this is basically the OpenTelemetry eBPF instrumentation. In short, it's called as OBI. So you can definitely check it out on, as Bill mentioned, right? It's not like one versus other. It's how you can use it in a complementary manner. And that's where you get, the most insights that you want according to your use case, of course. So yeah, I mean, I think this was an important topic to touch on because I see a lot of people have this confusion, and I think Bill, you answered it really well, because these are complementary approaches. So because we are talking about instrumentation right now, right? I think it's fair we talk about the challenges as well. I know we have touched a lot about what teams should consider, what teams should keep in mind, what they should be aware of as well. But I think we can have a few specific use cases in mind to talk about these particular aspects. So Rajat, just to start this off, because we have implemented an eBPF based solution in the past as well, right? So do you want to, I think it's a good time for you to kick us off and tell us a bit more about that and what challenges do you think we faced?
Sure. Yeah, I think one of the first things that we were interested, apart from sort of the security aspect of it, was tracing, and how you could do tracing with zero code instrumentation. Or I mean, that's a bit of a tricky term, but without them having to change anything, implement any kind of libraries or any of those things, how can we enable tracing? And there were some interesting projects. So Pixie was one such project that tried to do that. One of the challenges that we faced was when it came to layer 7 visibility. So layer 4 was amazing. It's just you just turn it off and you get a nice little network map right off the bat. A lot of things work really well, but when it comes to layer 7, you start to get into challenges. So anytime a library changes, because the method signatures have changed now, it's no longer working. So for example, we had when we move from one Kafka version to another, all the Kafka related information we were getting suddenly disappeared or started acting out weird and giving sort of wrong information. But when it worked, though, it was beautiful because you literally just point at it and it picks up everything, and it's very rich sometimes, the data you get. We didn't have this kind of challenge with HTTP because it's a very mature protocol. The libraries are fairly stable, but in a fast-moving protocol or something that's constantly being developed. So, for example, when you move from one Kafka version to another, we ran into those challenges. I don't know if that's the right approach when it comes to layer 7 related stuff, but there is no shortage of people trying to sort of get to that level, and there are open source projects, and also observability vendors who are sort of going after this. Bit of a holy grail in my opinion, but what are your thoughts on that? Is that even advisable? Should people not think of it at the layer 7 level, because you need extra information to correlate? Like you said, eBPF is very low level. It doesn't know anything at the application level, certainly not things that are running on the user space. So you need some sort of correlation and coordination. What are your thoughts on that?
Yeah, this is a little bit about how eBPF is innovating itself. So I know we went very quickly over kind of like what eBPF is and the history of it, but kind of like another important part to kind of bring up here is that eBPF, because it has this verifier, it's like checking to make sure it's safe to run. There's a lot of limitations on what you can actually do with eBPF to ensure that the code is safe to run in the kernel, because you obviously don't want to crash the kernel. And so one of those is actually like a limit on the number of instructions. So when eBPF was first merged into the kernel, there was a limit of 4K instructions per program, right? So pretty small program. Now they've been able to increase that to 1 million instructions. And there's other kind of like limitations around loops and other things. It's changing as the eBPF ecosystem continues to evolve, and we can verify programs to make sure that they're safe while still kind of working in existing limitations or kind of pushing those limitations out, going from 4K instructions to 1 million instructions. But there are some limitations in terms of what eBPF can do. And this is, I think, kind of like where it started, is like, oh, eBPF can't do this, eBPF can't do that. But that has actually like changed a lot in eBPF. There's actually Liz Rice, my boss, she actually recently did a talk and a blog post about how eBPF is now Turing complete, right? You can write anything that you want to. You could write Doom in eBPF. The question is whether you actually want to, and what's the benefit that you get from that, right? So eBPF is still a complex way to write a program. Running things in the kernel is like more complicated, has less flexibility than running something in user space. So I think when you're thinking about, can I do this with eBPF? The question is, or the answer is yes. The real question is, should I do this with eBPF?
Yeah.
And the answer for that isn't always yes. I think there's a lot of things that'll go back and forth. I think it's been interesting kind of seeing the transition of moving more things into the kernel, especially on the networking side, because like we're really concerned about like throughput, performance, how we're actually doing these things. And so we actually we wrote in HTTP parser that works in eBPF in the kernel. And if you would have said that like 5 years ago, people would have been like, no, you'll never be able to do that. But because of kind of these innovations in the eBPF ecosystem itself, being smart about how you actually do it and implement it and program it, it's like, yes, you can do L7 parsing in the kernel with eBPF. So that's something that we do now. So then the question is, like, what are you actually trying to achieve? What are your goals? What are the trade-offs that you're willing to make? And I think that's a question for actual implementation. If you're writing your own eBPF programs, you need to evaluate that. And if you're looking at different vendors or different projects, you're going to be like, what use cases are most important to me? What solutions am I trying to do? Am I looking for speed, performance, complete flexibility? And looking at those trade-offs. And that'll help you understand, is this something I should do with eBPF? Because the question of whether you can do it with eBPF is yes, but that doesn't always mean you should.
Okay. Great answer. Definitely, yeah. Those protocol passes are one of those use cases that we were after, and when it works beautiful. It's just it's like magic. You turn on and you can see everything. Like Kafka was one of those things where you can see from the consumer side, like everything that kind of goes to the wire. But to your point, exactly. Like just because you can do it, should you do it? And there are lots of trade-offs to sort of consider. What we can safely say is that the eBPF has sort of come a long way from like hype a while ago to very concrete use cases where people are continuously pushing the envelope to see where it can be applicable. So what do you think would be next? Like where are you seeing it's kind of going right now? Where it started with like just networking and security side, to people trying to do things like what I talked about, like protocol passes, and try to do more high level tracing. What are some of the other use cases you've seen people are tapping into, and where do you think it's heading?
Yeah, so one of my favorite lines from the eBPF documentary that you posted the link to at the beginning is from Thomas, and he's the founder of Isovalent, or one of the founders. And the line that sticks with me is, suddenly we realized we could rewrite everything better. What should we rewrite first? And their answer to that question is networking. That's how Cilium came in. That's how Isovalent came to be. That's kind of like the whole history of our company. And then we saw, Brendan Gregg tackle observability, tracing, profiling at Netflix. We saw other people tackling security with eBPF. And it's kind of like you can replace a lot of different parts of the Linux kernel with eBPF. I mean, I've even heard ideas of like writing a whole kernel just in eBPF and providing just the functionality that you need. Then you can do things like micro and uni kernels with eBPF. I mean, there's lots of wild ideas. But the one that I actually really like right now is, once again, getting back to this like innovation cycle, right? Innovation slowed down in a lot of parts of the kernel because it's like, okay, we have a standard implementation of this. It works well for most people. Like, we stick with that unless you can actually prove something. And so actually one of the areas that is probably like not changed that much is actually Linux kernel scheduling. There's a completely fair scheduler in the Linux kernel, and it works great for a lot of use cases. But, there's always some edge cases, some very specialized things. For example, like gaming, you care about different things than like an e-commerce website. If you think about like what the application actually looks like. And fundamentally, they're using the same scheduler in the kernel, right? And so what's cool with eBPF now is you can write your own custom scheduler, right? And I think that's really cool. It's like, once again, like, how do we bring innovation back into the kernel? That's one way. It's like, before, the idea of writing your own kernel scheduler was like something maybe you could do a computer science class. And it's like, oh, now you can actually write one. Like, the two funniest ones that I've seen is like somebody wrote a scheduler that was based on them singing. So it's like, as audio inputs coming in, that's how it schedules the programs. The other one that was really funny is they literally made an astrological scheduler, and based on the star signs, like if like Venus is in retrograde, and like it's like Sagittarius right now. It's like, this is how your programs are scheduled. So you can do a lot of things. Like, obviously, that's not one to put into production, but it kind of gives you the idea. You can, okay, we have a different type of workload. We have different requirements. We have different problems that we're trying to solve than this specific thing is. And suddenly we have the power to do things differently. And that's what eBPF enables.
That's actually amazing to kind of hear these wild sort of ideas. That's the important part is that we are only limited by our creativity, so we can come up with all of these different things. One of the other things that if I may quickly touch upon, at least in the past, you needed sort of specialized knowledge, at least some idea. To your point, you said like, most people should be consuming, applications like Cilium or, Kubescape or Pexi that is written on top of eBPF. And you needed some knowledge to write these eBPF probes in the past. And, the larger companies had access to that. But with, generative AI and other things that are making things a little bit more, approachable, covering the knowledge gap. Do you think they will see a bit of innovation where people who were limited by, knowledge before, skill gaps in certain areas, are now perhaps able to kind of, tackle into this? I mean, it's impacting everything around us, but I was curious to know about this area.
So this is the debate about how much do you believe in AI coding agents? And I think there's a lot of theories and opinions out on that right now about how good they are. And I do think like there are some cool use cases about, if you understand one area, being able to re-leverage kind of your existing knowledge and the computer's existing knowledge to expand into a new area. Like I know some of our kernel team is like obviously very smart people, but they don't know about, for instance, we're actually looking at how do we do bring essentially the power of eBPF to virtualized networking, and VMs and containers running VMs running in containers on Kubernetes, and like we don't know as much about like, some of the KVM, QEM type of things. And so it's like, okay, we know a lot about the kernel, but not this specific part because we were focusing on other parts. Can we take this, learn a little bit from AI and do things like that? But that's how much do you believe in AI coding agents? I think maybe the better answer to this question is like, you don't have to know about eBPF to actually benefit from it. I think that's the coolest thing. My favorite example is the majority of the world's actually already using eBPF, and it's sitting right here in your phone. So any Android operating system is using eBPF for network statistics. So if you want to know how much data did I use this month, how much do I have left, well, you can thank eBPF for that. And so if you think about the number of Android devices out there in the world, I mean, you're already looking at most of the world using eBPF, right? Yeah. And so this is, once again, even if you're not using the super low level technology, there's the products and the projects on top of it that are using that are allowing you to still benefit from it too.
Totally agree. Yeah, I love that line. You don't need to know it to reap the results of what it can provide it to you. Yeah, love that point. Alrighty, I think in the interest of time, we are at the end of this one. I was just scrolling through the chat to see if I haven't missed any particular question. There is this interesting one by Swapnil. He's asking about what could be some business related use cases of eBPF.
Yeah, so I saw one of the comments later was about blocking domain requests based on business requirements. And actually, I don't remember the exact name of the GitHub repo, but if you type in something like Spotify ads in eBPF, there's actually a project where somebody used eBPF to block the ads on Spotify based on like the IP addresses where the different information was coming or something like that. But if you look it up on GitHub, there's a project out there that does that. So yeah, so depending on your business requirements, whether it's blocking ads or something else, you can do that with eBPF too.
That's interesting. Yeah, how much like people are creative, and if you put an innovative tool like eBPF in their hands, I mean, anything could happen, right?
Yeah, I think that's the fun thing. It's like it allows you to innovate again. It allows you to ideate again, and you never know what human creativity will do.
Amazing. Yeah. I think we have answered most of the questions here. Folks, if you have been watching the session and if you have more questions, feel free to comment them down below. And I saw one comment by Rafael. I hope I'm pronouncing the name correctly. Sorry. That they don't see the links. So this is a bug from LinkedIn, folks. So I'm really sorry about that. If you want to access the links that we shared throughout the session, you can head over to the YouTube live stream. I have shared the link for that here. You can go there and you'll be able to access it from the recording as well once you want to, if you want to access those, because we have shared a bunch of interesting links as well. All right. Thank you so much, Bill. It's been real. We've had an interesting conversation. eBPF, I think, is not something that you can just cover in a 40-minute chat. There's a lot more to it, right? And we'd love to have you in another conversation as well sometimes to talk about the internals of eBPF if someone would be interested in that. But yeah, do you have any closing remarks for people who are watching till now?
Yeah, I think it's just kind of how I talked about it last. eBPF allows you to innovate again, and now it's up to you to use your creativity to figure out how to use that.
Amazing. Yeah, it's been real. Thank you so much, Bill, for taking out your time, and thanks everyone for watching. You can access the recording on LinkedIn and YouTube as well, and feel free to reach out to Bill. Feel free to follow him on all the platforms. He's doing some amazing work, and we'll see you in the next episode of Observability Unplugged. Bye-bye.
Thank you, Bill. Appreciate it.